Hi, I'm Ben Lanir. I'm an electrical engineering major.
Hi, I'm Blake Lazarine. I'm also an electrical engineering major.
Hi, I'm Thomas Sison, and I'm also an electrical engineering major.
We made a smart home device as our final project.
With the prominence of voice recognition, smart home devices, and the Internet of Things in our world, it is important to understand how these devices work. A good way to get an understanding of these devices is to build one from the ground up. This will allow us to see its mechanisms and its limitations. Our project aims to use physics in the form of sound waves and mathematics in the form of the Fourier transformation to create a smart home device which can recognize and execute commands. Okay.
In theory, we should be able to take a human voice, convert that to a sound wave, and then do a Fourier transform analysis on that in order to find certain peak frequencies. And from those peak frequencies, we can make a string of commands. However, due to the range of frequencies that the human voice can output, we decided to limit it into certain consistent whistles that we found, and we found that we were able to make three certain whistles that we can distinguish. Although even with these three distinct frequencies, you can make a theoretically infinite number of possible commands. Okay. Implementing the hardware for this project brought its own problem in the form of we had to balance the amount of input pins we have as well as the amount of outputs that we can use. For this project, we had a microphone input that connects a 3.5 millimeter audio jack into our phone, and from there that can record our voice. For our outputs, we have an auditory response in the form of a buzzer, as well as two visual responses in the form of red, green, blue LEDs, as well as an LCD screen output that can print out up to 32 characters separated between two lines. However, the main problem with this is that we use about 80% of the available pins on the Arduino, leaving only most of the analog pins, as well as only a couple of digital pins left for additional expansion. Okay.
So to make all of this come to life, we had to make use of both the Arduino and Python tools. The Arduino was primarily used for taking in microphone data and executing IO commands, whereas Python was used for performing Fourier transform on the microphone information and recognizing sequences and commands, sending songs and sending text. But in order to make these two systems work together, we had to devise our own serial communication protocol to keep them synchronized. The system we devised used a speak only if spoken to type system, where the Python script would send commands to the Arduino via serial, such as read information from microphone, play a note, write a message, just things like that. And the Arduino would upon hearing this, would take a measurement, execute a command, and then send back either a handshake, just to acknowledge that it received a command, or it would send back data such as that from the microphone. When devising this, we had to account for there being very limited data storage space on the Arduino. So if we wanted to have a vast library of songs or jokes or anything that we wanted our voice assistant to be able to do, we needed to store that on a larger storage system, such as our laptop, and use our communication protocol to send complex pieces of data to and commands to the Arduino, which we were able to do through our protocol.
We decided to use whistles because whistle tones are very easily distinguishable from each other. We discovered that we could have three separate ranges of whistle tone frequencies, which Python was able to accurately detect 90% of the time. These ranges were 750 to 1,200 Hertz, 1,200 to 2,400 Hertz, and 2,400 Hertz and up. Each of these ranges we assign a number, 0, 1, or 2 respectively, which we use to create commands. If the peak frequency of the sound recording was below 750 Hertz, we discarded that sound to account for any background noise or pauses in the user input. Okay. Here are examples of how Python would detect the three different whistles. So in the top right, we have the low whistle, the bottom left, the medium whistle, and the bottom right, the high whistle. You can see that each one has a peak and then some background noise. Python discards the background noise in favor of just the peak. The ranges give us some space to not have to produce the exact same whistles every time. Okay.
Now, taking a string of whistles, we can translate them into certain commands. Some of these commands are simpler, such as just turning on or off a light, or using a collection of these LEDs in order to make a certain light show. However, we were able to make more complicated commands by combining Python and Arduino, such as playing a song, which essentially takes the MIDI file of a song and converts it to certain frequencies, which we play at a certain time using the buzzer. However, due to our limitation of only one buzzer, we restricted ourselves to only using the easily distinguishable songs.
Another example of more complex commands we could output is printing text, such as the time or the weather. In order to do this, we had a specific text function in both Python and in the Arduino. In Python, the text function would send a message to the Arduino to let it know to activate its own text function. Then it would send over the text needed. The Arduino would receive the text, and using its getText function, it would look at it and then output it to the LCD in 16 characters at a time.
So,
Here's an example of some text.
Here's an example. This is from our tell a joke function. So the joke that we are displaying here is, what did the pirate say on his 80th birthday? I'm
matey.
And here's a demonstration of our system in executing a full command by playing a song.
So, conclusions. Our Arduino was able to successfully pick up the whistles and give the data to Python. The Python portion of our project was able to successfully detect the whistles. From whistle being made to a command being executed, Python was successful 77% of the time. We noticed that there were about 5 seconds of latency in between when we sent a song command and when songs played, and about 3 seconds of latency in between when we sent a text command and when text was displayed. This is due to communicating between Arduino and Python over serial, which has inherent delays in it. We also had to overcome the limited space on Arduino, as discussed earlier. Okay.
This latency is why we skipped a few seconds in the middle of the demonstration video.
There are a number of ways we could expand this project in the future to make it more useful. First, we could use voice instead of whistles. This would allow for more intuitive commands and a wider range of command inputs. Second, we could add some kind of wireless capability, such as Wi-Fi or Bluetooth, which would allow it to connect to more devices and it would give it the possibility of becoming a full smart home device because it would be able to interact with other items in the home. We could also add an integrated microphone, which would allow for more sounds to be heard and sounds to be heard from farther away.
We would like to thank Edgar for sponsoring this project, as well as all the resources online that helped us learn about this, as well as the songs that we use for this project.
Yeah. All right. Thank you, and
thank you.
bye.